So this is the science behind how the concentration of the reactant, in your case the solution B, affects the rate of reaction, so how long it took the X to disappear. So what was actually happening was the strength or concentration of the reactant affects the rate of reaction because of the collision theory of particles. As you increase the particles in the solution by increasing the concentration, there are more particles present to collide with other particles in a shorter time frame, and this causes the reaction to speed up. So it's similar to how amount increases the rate of reaction, except that instead of adding more of something, you're actually making it stronger by having a higher concentration. So having a higher concentration of the reactant means that there are more reactant particles in the same volume or the same amount of the chemical. So you added solution B, and you changed the concentration of that. When it was 100%, it had more particles of solution B in it than anything else. And so that was a really strong concentration, so the reaction rate was quite high because there were lots of particle B banging around with the other particles that were in there and causing the rate of reaction to speed up. 80% concentration had 20% less particles of solution B than the 100%. Because there were 8 mils of particle B in there and then 2 mils of water. So you weakened it by adding a different concentration. So that means that there were less particles of solution B to bang into the other particles in the other chemical, and therefore the rate of reaction would have been a bit slower. So copy this note into your notes. If you're using the drag and drop notes, then it is slide 35. And then you will need to do the questions on the next slide. So pause this, copy in the note, then start it again for the next slide. These are the questions you're going to answer using the notes from before. So answer these in your book or on a new slide in your drag and drop notes. Pause it to answer them and then start again for the next task. Okay, the next task is we're going to look at explaining how concentration affects the rate of reaction and why the concentration affects the rate of reaction. So we've already done that a little bit, but we're going to look at it in a bit more detail. So to do that, you're going to have to look at the information on this web page, and we've actually already seen this information when we looked at temperature, but now we're focusing on the concentration side of it. And then you've got to draw the graph that is showing the effect of increasing concentration on reaction rate. So you can draw that into your notes, or you can just copy and paste it into your notes or the Google or the drag and drop slide. And then you're going to copy the list under changing the concentration. Again, you can copy and paste that, or you can write it into your notes. And then you're going to use the information to write a paragraph answering the part above. So I'll talk you through that as we go. So first of all, we'll click on this web page. And for those of you using a computer, you can click on that link also, or you can just look at what I pop up on the screen here. So we've seen this already. Before we focused on the temperature stuff, now we're focusing on the concentration. So it says here, increasing the concentration of the reactant in the solution can increase the rate of the chemical reaction. We're going to look at this graph here. So as you can see with this blue line, as you have a higher concentration, the time of the reaction is shorter with the amount of product made. So more product is made early on in the experiment, and then it starts to flatten out. Whereas if you have a lower concentration, you've got less product being made originally, early in the experiment, and then over time that increases. So it happens much more slowly. So having a higher concentration causes much more product to be created early on. So copy this graph here into your notes, and then also copy this part here about changing the concentration, because they're a good summary. So it says if the concentration of the dissolved reactant is increased, then the reactant particles become more crowded, and there is a greater chance of the particles colliding, and the rate of reaction increases. So put those notes also into your notes. Once you've done that, then go back to the PowerPoint here, and we've done these 3 steps now. We're going to do this final step. So using the information to write a paragraph response to this part here. So you need to write a paragraph that says how the concentration affects the rate of reaction and why the concentration affects the rate of reaction. So you could draw in the graph, Or you can use your notes that you've already written in and that list that you just wrote in and put it into your own words to explain how concentration affects the rate of reaction and why concentration affects the rate of reaction. Then either share that paragraph with me or give it to me to have a look at.